So, as we said, you have to do the exercises at the end of the chapter to understand all of these concepts together. So, we look at the attach flow and we highlight what are the security aspects. We have covered some of the other aspects of the attach flow during the LTE attach lectures, and you should go back and take a look at that if you want to understand those aspects. Here, we will only consider the security aspects. So as the mobile attaches to the network, it goes through a random access procedure followed by an RRC setup, which ends up with the mobile sending the NAS message, which is attached along with its IMSI in the attach in the clear over the radio, along with a NAS message for PDN connection. That means please give me an IP address also. So the IMSI is being sent in the clear, as we said. So this is the one place where in LTE you can snoop the IMSI over the air. When we look at 5G, there have been new mechanisms that have been brought into place to make sure that even during the initial attach, you do not have to send, the mobile doesn't have to send the IMSI in the clear. But for that, you'll have to wait till we cover security for 5G. And once this message comes in to the eNode B, it goes ahead and selects the MME, and it sends the NAS attach message to the MME. Part of the attach message also includes the UE network capability, which are a list, which amongst other things, a list of encryption and integrity protection algorithms that the mobile supports. Now, in LTE, as also in 5G, there are three algorithms that the mobile is required to support. The very first algorithm is the null algorithm. That means no encryption or integrity protection. The second one is the SNO 3G algorithm, which has to be supported, which is required to be supported by the mobile and the network. And the third one is the AES algorithm, the advanced encryption system algorithm, that needs to be supported by both the mobile and the network. So the UE goes ahead and provides the UE network capability, and if it has any other optional algorithms that it supports, it can provide that in the UE network capability. So based on that, the MME knows what algorithms are being supported. The MME has a prioritized list of algorithms that it would that it would use based on what it would like to use. So if AES is given as priority number one, then that would be the algorithm that would be used for encryption and for integrity protection. And it's the same three algorithms that are for both encryption and integrity protection. The null algorithm is the one that is actually used primarily for enabling emergency calls without a SIM in the phone. So emergency call needs to be set up even if there is no SIM in the mobile. An emergency call should go through irrespective of whether there is a SIM or not, and that's the reason why the null algorithm is a fallback algorithm, which is actually no encryption and no integrity protection, which is used for emergency calls. So the UE network capability is provided in the attach accept message, and after that starts the authentication, the user authentication procedure that the MME sends the authentication request information to the HSS, and we get the authentication vector, the four KSMA authentication code, random number, and expected response. The MME goes ahead and then sends an authentication request message to the mobile via the eNode B, and that gets sent again. It's sent out in the clear, and what comes back from the mobile is an authentication response, which includes the response value that the mobile sends by using the algorithms that by using the authentication procedure that we had covered in the previous slides. And MME compares the response that the mobile has provided with the expected response that it had gotten from the HSS, and if it works out, then authentication is successful, right? So this is the authentication procedure that happens during attach, and actually this can happen even during any time that the network decides to re-authenticate the mobile. Everything from step number 7 all the way to step 12 happens anytime and every time re-authentication needs to be done for the mobile. Once the UE is authenticated, next comes the NAS security setup. So this is the part where the encryption and integrity protection algorithms need to be decided between the mobile and the MME. So the MME goes ahead and it sends basically the selected NAS algorithm. So if the highest priority, for example, in MME was AES algorithm, then it would go ahead and say, I want to use AES for integrity protection and for encryption. The MME also includes the UE security capabilities in the security mode command for protection against bidding down attacks, and the way the bidding down attack, which as explained in the specification, is that there can be an adversary in the middle that could go ahead and modify the UE network capability by only including those capabilities that are weak algorithms. For example, it would say that the mobile only supports SNO 3G but doesn't support AES, where AES is a more secure algorithm than SNO 3G. I'm just using it as an example. So it kind of removes AES from what the UE had actually sent. The UE had sent that it supports SNO 3G and AES, but the adversary kind of sends to the network that AES is not supported. And what the MME would go ahead and do is, by replaying the UE security back to the UE, it's saying that, okay, you only sent me SNO 3G, so I am going ahead and selecting SNO 3G. When this message comes to the UE would find out, hey, something is wrong over here. I had advertised that I am supporting AES, but the network did not get that part. So there is an adversary in the middle who is bidding down to a lower secure algorithm than what is supported, in which case it would reject the security mode command and send back a message saying, hey, there is a bidding down attack. So that is at a high level the reason for replaying the UE security capability back to the mobile in the security mode command. And there is also an additional parameter, which is the key set identifier, the EKSI, or the enhanced key set identifier. The reason is that this is a shorthand index to the keys to the authentication vector that is being used, to the KSME. And this actually comes into play when there can be cases that there are multiple key sets that are being used, and those are the more advanced cases if you have handovers from 3G into 4G, where you could end up having two different security keys that are being used, one from a mapping of 3G to the 4G keys, and another which is a native 4G key. Now that's an advanced topic that we will not cover in these lectures, but there is also a handle to the key set that is being used, which is the current key set that has been provided by the HSS. So this is a pointer to the keys that are to pointer to the KASME, which is used for which is going to be used for encryption and integrity protection. And it sends this message. This message is does have a MAC code to it, so it is integrity protected, but it is not encrypted. So the security mode command is sent integrity protected but not encrypted, and that goes all the way to the mobile. The mobile makes sure that the integrity protection is correct because it has already derived the KSME after the authentication, and once it does do that, it goes ahead and sends the security mode complete message, which is encrypted and integrity protected. So it has both encryption and integrity protection, and it sends that. So once the mobile gets security mode command, it starts encrypting and integrity protecting all messages going up into the MME. And keep this in mind, because when we do look at the access stratum security mode command, there are slight differences that you may want to keep in mind. So once the security mode command is received, so essentially the NAS algorithm has been agreed between the mobile and the network. The network is the one that selects the NAS algorithm, and both for encryption and integrity protection, and the mobile just has to use the algorithms that the network has sent that. And with this security mode command completion, we have the NAS security, which is set up between the mobile and the MME, and all NAS messages from here on will be encrypted and integrity protected in both directions, right? Once this is set up, the next part is the authorization, which is actually fairly simple in LTE. The MME goes ahead and does a location update request to the HSS, where it registers itself with the HSS and also requests for subscription. The subscription data has essentially all the services that the mobile is authorized to use. So this subscription data would say whether the mobile is allowed to use internet, or whether the mobile is also allowed to use IMS voice or VoLTE, voice over LTE, or not. And this is essentially the authorization phase of the attached procedure. So this is actually pretty simple. It's everything. All the authorization is in the subscription data that comes down to the MME. Now, once this is done, the MME will proceed, and it creates a GTPC connection between the MME serving gateway and the P gateway, and details of this are covered in the LT attached. There are no security aspects in here because in the core network there is no additional security that is being provided for GTPC. Now, once that has happened, now is the second part. The next part of it is setting up of the radio resources. So the mobile, so the MME goes ahead and sends an initial initial context setup request. It provides the UE security capabilities that the mobile had provided as part of the UE network capability, and the MME also provides the KE node B to the E node B that should be used for the keys for the access stratum. Now, based on the UE security capability, the E node B also has a prioritized list of algorithms to use for the access stratum, and typically the same prioritized list as what exists in the MME. So in most cases, the algorithm used on the access stratum should be the same as the algorithm being used in the non-access stratum, though it is not all going to be always the case. So you could have a case that the E node B has a different prioritized list of algorithms than what the MME, in which case the access stratum algorithms for encryption and integrity protection can be different. As part of the initial context setup, the MME also sends the NAS attach accept, which is encrypted and integrity protected, so does have the message authentication code attached to it for integrity protection, and also the activate default bearer request. So that is for basically setting up the IP connection for the mobile. Which is again encrypted, integrity protected. It also includes the GUTI, the globally unique temporary identity, and the tracking area to which the mobile is admitted to. And as long as the mobile is in the tracking area where it is admitted to when it goes idle and comes back, it does a service request. We will cover aspects of some more aspects regarding this during the mobility lectures, but suffice it to say that the mobile is admitted to certain tracking areas when it as part of the attach accept. Now the next part of it is the setting up of the access stratum security setup. So the access stratum security mode command then gets sent from the eNodeB to the MME, and this is again integrity protected, but not encrypted. So it does have the message authentication code along with the access stratum algorithm that has been selected for it. The mobile goes ahead and sends a RRC security mode complete, which is integrity protected but not encrypted. So this is slightly different from the NAS security mode complete, which was also encrypted. After this, all messages between the UE and the eNodeB will be encrypted and integrity protected. And both SRB1, which is used for RRC messages only, which is having higher priority, are encrypted, integrity protected, and SRB2, which are used for NAS messages that come from the MME and sent to the UE, would be encrypted and integrity protected. So with RRC security mode complete, we have the access stratum security, which has been set up between the UE and the eNodeB, which is complete over here. And once this security is set up, the eNodeB can go ahead and request for UE radio capabilities from the UE using encrypted and integrity protected messages. And along with that, after SRB1 and 2 has been set up, it goes ahead and does the RRC reconfiguration and provides the NAS messages and provides that piggybacked into the RRC connection reconfiguration message to the mobile. And the mobile reconfigures its radio and basically sets up a data radio bearer for the IP connectivity that it has, and it first sends an RRC reconfiguration complete message. Actually, it sends that in SRB1, and that kind of and then based on this message coming back, the eNodeB sends an initial context setup complete message, including the S1 UTE-ID to the MME. There is no additional security aspect in this message. Once we have this, we continue on with the mobile sending actually an attach complete message and also an activate default bearer accept message back, which is to the network. Both of these are encrypted and integrity protected. And once these messages are received at the MME, it goes ahead and provides the downlink S1 UTE-ID to the serving gateway. And with all of this, you have essentially the signaling connection complete between all the way from the mobile to the packet gateway, with the SRB1 and 2 being encrypted and integrity protected. And on the user plane, the data radio bearer is encrypted but not integrity protected, right? I mean, as we said, this is only encrypted but not integrity protected, and the rest of this is there is no further security based on at least the keys that the UE and the network created. So with this, we complete the attach procedure. Just to keep in mind, one last thing about the fact about identity protection is that if the UE does a subsequent attach to the network, it doesn't include its IMSI, but it includes the GUTI that has been provided by the network. So in the subsequent attach, if it does have a GUTI, it provides the GUTI and it integrity protects this message. So in a subsequent attach, the IMSI is not provided, and the same thing is with the NAS. PDN connection request message is integrity protected using the keys that had been provided in the previous attach. And it also provides, as part of the RRC message, in RRC, the message number 5, RRC message complete, it provides the globally unique MME ID that is part of the GUTI to the eNote B, and the eNote B can use it to go back to the old eNote, to the eNote B, to the MME that had provided the GUTI. But let's assume in this case that the mobile has moved from one region to the other, such that this eNote B is no longer connected to the old MME. So this old MME was, for example, let's say is in the New York area, and the mobile has moved down to Florida, and the eNote B in Florida is not connected to the MME in New York. So this eNote B figures out that it can't connect to the MME in the GUTI, but it will select basically an MME that it is connected to, and it sends this initial UE message, which includes the GUTI and which is integrity protected. But now, with this GUTI which is in here, this new MME can go ahead and find out what the old MME is based on the identity provided in the NAS request message, and it sends the complete attach message with the GUTI and integrity protection to the old MME. The old MME in basically does the integrity protection check, figures out that whether this check is correct or not, and if it is correct, it says that it's verified. It then provides the IMSI and the mobility management context, which includes all the security contexts, all the UE security capabilities and everything, back to this new MME. And now this new MME can go ahead and continue with the attach procedure, and it may even skip re-authenticating the mobile if it does decide that it wants to just continue using the security contexts that have been provided by the old MME. Though it is recommended that the new MME does do a new authentication for the UE and creates new keys. It'll definitely change the GUTI, because the GUTI will now have to map to the at least the MME identity in the GUTI needs to map to this MME as opposed to the old one, right? Not to the New York one, but to the Florida one. One last thing about the about service request, and that's the case that the UE is still in New York and it went idle, and next time when it goes active, when it sends the NAS service request, in this case, the only thing which is in the service request is the key set identifier, and the service request is integrity protected. It is not encrypted. One of the reasons for a lot of these initial UE messages not to be encrypted is that you do want the network to find out what the mobile is trying to do. Does it have a new message to send, or is it trying to do an attach accept, or it's trying to do a tracking area update? So these messages, which are the very first messages that are sent, are from an idle to connected state, are called initial UE messages. And the initial UE messages, which are basically attach request, or a tracking area update request, or a service request, these are sent integrity protected but not encrypted. So these are not encrypted. And that is where, I mean, you some of the information that is sent is out in the clear. So the service request message has the index to the security keys that is being used as integrity protected. It doesn't even have the mtimsy of the UE. So how does the context get figured out? And the answer to that is that as part of the RRC connection request, the mobile sends the STIMSy, basically the MME code, and the MTIMSy as part of the RRC message, and then this gets relayed to the MME by the eNode B as part of the initial UE message sent in S1 AP. So this part, the MME code and MTIMSy comes in STIMSy. The key set identifier index comes in the NAS message, and along with these two things, the old MME is able to find out the context of the UE and the security key and go ahead and further process, further do the service request. There is an option that this MME may decide to re-authenticate the UE also. And if it does do that, it'll start with the authentication procedure from here going up to the HSS.